resistant to critical errors or self-correcting, because basically they're relying on circular logic. It'd be like if a company was serving as its own transfer agent or registrar, where the shareholders decide who the shareholders are, essentially. In that type of system, you eliminate the energy component, but then you put in more of a governance component. And so there's different models, but what makes proof of work interesting is that it's self-verifiable. So with proof of stake, it's costless to create an infinite number of copies. And then the question becomes, what is the real ledger? What is, the official canon ledger? And so it kind of comes down to a, majority decision, more or less. Whereas in Bitcoin and proof of any sort of proof of work blockchain, the longest chain that follows the rules is the canon chain, and it's self-verifiable. So no matter who gives you that blockchain, your node can verify that, yes, this is the longest blockchain I'm seeing. It follows the rules, and therefore it's the one I'm going to use unless I find a longer chain out there. And so it's the best we have, the best we know how to make a decentralized ledger. The most challenging issue with proof of stake is one that it's basically circular logic. And because it's circular logic, the complexities involved in making it work, like if the code base is like 100 times more complex than proof of work, because you're trying to solve for the fact that it kind of inherently doesn't make sense, but you can, with enough smart programming, you can make it make sense. But then the question becomes a matter of community governance. So it ends up being kind of like fiat currency, where it's very reliant on the ecosystem participants having these kind of rules that they follow, and then, not corrupting that over the long arc of time, which we know is very hard to avoid have happening. So obviously gold has the much longer track record, and it works. Even if the internet goes down, I mean, you can still use gold and silver to transact. And it's basically, gold is the highest stock to flow ratio commodity, meaning that the supply inflation rate per year compared to the existing estimated stock that exists is very low, something like 1.5% per year on average of supply growth. So if you imagine a money that had a 1.5% supply inflation rate, broad money supply growth over the long term, that'd be a pretty attractive money compared to most other currencies. The dollar grows on average something like 7% per year. Most emerging market currencies grow much faster than that, whereas gold is basically this very slow supply growth currency. And it's something that there's no central authority that can just print more of it, and so that's why it's had this very long track record of holding its value. Plus, it's nearly indestructible in the chemical sense. The shortcomings are basically its portability and speed, right? So you can't use gold to transact with someone in another country unless you abstract it in some way. It's basically only suitable for local commerce, and as once we put undersea telecommunications cables in the late 1800s, we've been able to transact globally, much faster than we can move around gold. And so we had to abstract gold more than it already was at that point in order to basically keep up. And then it was able to be dropped away from the money system, other than as, kind of these opaque sovereign reserves. And whereas Bitcoin, there's multiple advantages. One, it's basically it's as scarce as gold, but then it moves as fast as fiat. You can settle a multi-billion-dollar transaction in an hour. Basically it depends on how much confirmations you want to wait for, but basically it's a very quick network at coming to a final settlement for all practical purposes. And then with things like Lightning, you can do these instantaneous payments on top of it. And so it's basically this very efficient system that in some ways combines the strengths of both fiat and gold, with the downside being that because it's open source, anyone can copy it. And so kind of like how gold is sometimes under threat from, say, paper claims on gold, people that think they own gold, but that, if kind of the music were to stop, not all those claims are maybe tied to an ounce of gold. You kind of see the same thing in Bitcoin, in the sense that, you can have literally tens of thousands of altcoins come around, and then that can dilute market share and market and network value if that kind of persists for a long period of time. And so basically it has to fight for market share among thousands of other alternatives. And so that's, I think, a very long process. And of course, it's only a 13-year-old asset. There's always risks of bugs. There have been some bugs in the past. One thing I like to point out is that Bitcoin, it's had 100% uptime since 2013. which not even Fedwire has. And so it's a shockingly robust system, but it's not without tail risks and bugs that could, disrupt it. And so, I think that in many ways Bitcoin is an improvement on gold, but it's not superior to every possible variable. There's still kind of a role for gold as well. When you look at gold, so an individual gold coin doesn't have any more energy cost. However, any sort of like transactions or using gold in any sort of economic sense does have an ongoing cost, because it takes time and energy, various types of resources to move it around.
The military, guys with guns.
You need, I mean, when Germany wanted to repatriate its gold, this ended up being a multi-year process, because obviously, it could have been done faster than that, but it's basically a complex process to move a lot of gold a far distance, and then to verify it all. When China buys gold from Switzerland, if they buy like the old type of gold bars, they want to remelt them down into a new type of gold bar, partly because that's one of the only ways you can fully verify that down to its core it is exactly what you think it is. And so the ongoing cost of storage, transportation, and repeatedly verifying that it is indeed gold does have an ongoing cost. And so there is some truth to the fact that if you have, say, gold in your house, that is, that's there for as long as you want it to. It is what it is. But the actual, quote unquote gold network does have an ongoing energy cost. Well, so I think, what we're seeing in Europe is it's a combination of problems. Obviously, there's underinvestment, and then, you can get away with certain shortcomings if certain risks don't occur. Whereas in this case, it did occur. You had, Russia's causing problems, and then also you have record droughts in that region. So you have like a 1-2 punch that's really kind of hitting them in all of the vulnerable parts around their energy grid. And for something like that, there's not a whole lot that Bitcoin can fix. But what I find interesting about the relationship between Bitcoin and energy is that people, when we talk about a resource cost for Bitcoin using energy, the kind of the first assumption is that's all bad. Basically, it's any sort of energy expenditure is a bad thing. Whereas we actually find that because of the unique way that Bitcoin consumes energy, it actually can be used to solve some energy problems. It's still a pretty small scale, because total energy expenditures, several $billion, but it's not like, hundreds of billions of dollars or anything like that per year. So it's still pretty small, but it can be used to kind of fix certain little issues. And there's a lot of people that don't have a background in electricity in various ways, don't know is how non-fungible a lot of our energy is. Right. And so they think that, if you produce electricity and you use it to mine Bitcoin, that you could have used it for something else.